Real quick, are you ready? I want to ask you, off the top of my head now, I'm just thinking to myself, I want to make sure you get some of those basic rules down, which is the key to making these problems easy. Every node represents what in these network problems?
Variable.
What is it?
Variable?
Constraint. A constraint.
The variables
Now, every arc represents variable. So you got those down, right? If I were to point at any one of these nodes, like this one, you should be able to tell me how many variables will be on the left-hand side of this constraint. That's right, you just count how many arcs you're touching. That's all. You know there should be 3 variables. Then figure out what they are. What about this node? Would the right-hand side be less than equal, greater than equal, or equal? That's right. Supply are all less than equal, unless you get a dummy node in, that's another thing. But assume these are all going to be less than equal, and assume that these right-hand sides are all going to be equal. We want to meet demand. So our plan is to give them exactly what they ordered. So I think you got that done. I want to take a step farther. I'm going to turn that, which we then turned into, what is it? This objective function. Every single variable, which means if we counted the arcs right now, it would be this many of them. Look, it's not even finished. And then the number on the arc, which is the cost for each unit being shipped. If I go back with the circles and I go the arc that's going from the supply node 2 to the whatever demand node 1, for every unit should be 7. There's a 7 on that arc. Now I want to repeat this. These numbers that are on the arcs are never ever in the constraints. I can't emphasize that enough. It's like just giving them points away by accidentally putting. The constraints only use the variables on the left-hand side with none of the cost numbers. Just the variables, x21, x22, x23, whatever it may be. Here's the variables. There were 3 nodes on the left, less than equal, 4 nodes on the right, all equal. Now, you take this, I want to show you how it's plugged into Excel. It looks a lot like that. Here is that grid of the costs. Here's our 3 supply, here's our 4 demands. This is the cost for every unit that we would ship from here to there. This, Boston has a demand of 6,000, Chicago 4,000, 2,000, 1,500. Cleveland, Bedford, and York, here's their supplies over here. You just create this like box. You typed all that part in. Here is the equation for the objective function, which you know is going to be every one of those costs times the optimal amount that will be shipped. Now there's what I want to point out. The optimal amounts that will be shipped are going to show up here, right here. So all these zeros for these 3 rows and these 4 columns right here are going to be your optimal solution. Numbers will appear here. You're going to tell solver, this is where I want you to put how much should be shipped from to. Here again, the demand from Boston, demand, demand, demand. This, look at this, right here. When the optimal solution's here, wherever Boston's going to get these from, they need to be, this is going to add those together. And when we open up solver, we're going to write a constraint that says this cell needs to be equal to that cell. But that's that constraint. It's basically adding these 3 together. It's got to be equal to that. Same thing's happening here with Chicago. Here's the 3 optimal solutions here. There could be zeros. That's how Chicago should get their goods. This is adding those together. And the constraint we enter in solver is this equals that. Now look at these over here. These are adding the row. It's saying wherever we're shipping to, here's what's coming from Cleveland. Here's an amount, maybe, 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 maybe. Whatever they add up to, when we put the constraint in solver, less than equal to 5,000, because that's all we can get from Cleveland, 5,000. And this, what I'm just trying to point out to you is you're taking it now from the story, let me get here, the story to a network. Then you're going from this network to this objective function and all your 7 constraints. Then you're taking it from that objective function and these constraints, and you are now going to Excel. This is a perfect way to set up transportation. Again, that is all of these times all of those. So this right here, when I click on it, you're going to see, what is that? This cell times that cell where the 3 is, that cell times that one, all added together, just like the objective function's written. So since there's what, 3 times 4, 12 variables? Whoa. Let me do this one. I got 12 of them going across. E9, I don't know why that one's there, E9, but, oh, there it is. E9 times, whatever that is, E24. F9 times F24. So you have 12 of these are going to be answers, 12 of these are your costs. That's your objective function. And this cell right here is using sum product, an easier way to write that, this cell times that cell, or this cell times that cell. If you want to take a shortcut, I just have an alternative way to writing it. Here's the long way. I'm happy with this one. Whichever way you feel comfortable putting the objective function. If this were on a quiz, you'd see a picture of this. Solver would probably be open here. And the question may say, if you clicked on E19, what would be the equation there using cell locations? And you're either going to answer using the long one like that, or you're going to use some product like that. Either answer is correct. That's one of those two would be entered right here if you saw the picture of the spreadsheet. And it's just the objective function formula, just using cell locations. Now, how to enter this into solver for transportation? Data, solver. Hey, getting all that out of there. Tell me you didn't see that. Where's the objective function set objective? Right there at E19. Is this a min or a max? It's a min. We click min. Where's the optimal solution going to appear? Let's pretend that's not there. The optimal solution are these 12 cells right down here, where they all have zeros in them right now. I'm going from Cleveland down to York, and then Boston all the way over to Lexington. There it is. This should be, what is that? E24, boom, boom, to H26, the bottom right-hand corner. Top left-hand corner to the bottom right-hand corner is telling the cell all the optimal solution needs to be in all those cells right there. Look at the, let me show you how to enter these now. Let me get rid of one. Let me get rid of both. Okay. Now I know that these are all going to be equal to, equal to, equal to, equal to, because this is our demand from those customers. And I know these are going to be, if I move this over, less than, less than, less than, equal to, because those are our supply. Let me move it over. So I'm going to do the equal to first. Add. The left-hand side are all these, the addition of that column, that column, that column, that column, equal to this column, that column, that column, that column. There it is. Every one of these sums need to be equal to the demand. Now I'm going to say, go back, you can see how it's in there now. Now I'm going to do the other one for supply. Every one of these, which is adding each row, have to be less than equal. It already is less than equal. All of these are what we can supply. Click OK. So it's just like we've been doing all along. The solver, the objective functions, this is where that equation is. By changing where the optimal solution is going to be, it's just a lot more cells in this particular case. The constraints are what's happening here and what's happening there. This has to be switched to simplex. Make sure that box is checked. What are the two reports? I can't remember the two reports. One is, let me go take a look. Sensitivity, right?
Yes.
And was the other one answer or limit? Good, I said. Was it limit or answer?
Answer.
I do it both because I don't remember. It doesn't seem like it would be, but I don't know. Where is it? Where's the answer?
Bottom left.
Just check. So then, let's say the output looks like this on the test. The question may say, how many should we ship from Bedford to Lexington? And you're going to put as a response what? What? Not 2,200. Where am I?
1,500.
Yeah, 1,500. That's right. All right, I said 1,500. Just a matter of, can you read this output? No. How many will be shipped from Bedford altogether?
6,000.
Yeah, the full amount. Would Bedford's supply have a slope? Is there some left over, for example? And what are you looking at? You're shaking your head no, but what is that? Everybody's shaking their head no. What are you looking at?
6,000.
Yeah, the amount being shipped from Bedford is 6,000. The amount they could capacity is 6,000. There's no slack or surplus there, whatever it may be. And by the way, let me think of this for a minute. If there were a difference here, right here to here, would it be slack or surplus?
Slack.
Why?
Less
Because the original constraint was less than equal. It's got to be slack, whatever, if there's a difference at all. Okay, so that's transportation. Now, let's get to transshipping. Come here, boom, 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 boom. Here's our drawing. You're reading the problem, and you're going, oh, hey, we're coming from here, and we're shipping here. And then you keep reading the problem, oh, wait, we're going from here then to here. And as soon as you recognize that it's going from one place to another, then to another, you're going to say, oh, this is transshipment. Because a lot of people go, oh, transportation. And then they realize, oh, wait, there's two shipments going on here. From somewhere to somewhere, and then on to somewhere else. It's got to be transshipment, no matter what the story says, even if it's not goods, whatever it is. Going from one place to another, then on to another is transshipment. In the middle nodes, what is special about these constraints right here? They're always, the right-hand sides are always what zero? Equals 0. The right-hand side on middle nodes are always equals 0 on transshipment. Always. Because the way I used to remember it is I always said, oh, well, whatever comes in goes back out. Nothing's left over here. So they're just breaking it up into smaller pieces to then get it out to the customers. So that's why that equals 0. Does anybody remember what I said about when you're writing this constraint? First of all, how many variables do you see in Louisville if you're writing that constraint? How many? 6. 2 here, 4 there. However many arcs you're touching, there's 6 variables. But because you have variables coming in and variables going out, when you write this constraint, you got to decide whether you're making the ones coming in positive or negative, and the ones going out have to be the opposite. If you made these negative, those have to be positive. If you made these positive, then those have to be negative. And once you do the first one, which will probably be this one, and you make that decision, positive and negative, you have to be consistent. And there could be 3 middle nodes here. You've got to be consistent. Once you decide the ones are coming in positive, the ones coming into every middle node have to be positive, or it won't be solvable. You have to have consistency. The next person says, I made the ones coming in negative. As long as the other person's consistent, the ones coming in on every middle node are negative, you're going to get the same answer. All right. So we take these and we write our, where am I? Blah, blah, blah. I want the whole thing. There we go. All those arcs were variables, and they all had cost associated with them, and that's your objective function. Notice every variable on the left-hand side of every one of these constraints has none of those costs involved, none of those numbers. That would be a huge mistake. It's just a matter of the variables. Now, I want to make sure you get this, so I'm going to go right here. Think about what this constraint would be right here. What's the right-hand side of that constraint? Equals what? 350. How many variables on the left? What are those variables? X plus X? Not 6. 3747. You just follow the arcs that are touching the node you're running the constraint for. And they would never be negative variables unless it's a middle node. And of course you got negative variables. What's coming in or what's going out, whichever way it is. We turn that into writing these, and I want you to see, here are the 2 middle nodes equaling 0. Notice in this case, the ones going into node 4 are negative, the ones leaving node 4 are positive. 4 arcs were leaving, 2 arcs were coming in. Node 3, 2 arcs coming in, 4 arcs going out, consistently. Negative coming in, positive going out. These are consistent, so it's going to work, it's going to be solvable. And then you have your nodes for supply right here. Here's your demand nodes. There's only 2 arcs on every one of those nodes, so you only have 2 variables. You know, you don't have to spread them apart like this. I think this is just for visual effect here. Now you decide, you're told, now you're looking at a transshipment on Excel. You've got to look at it and be able to figure out how to solve what all the cells are. And it looks like this. Is that different? What are you talking about? You have all the variables up there. It's just a matter of plugging either a positive one or a negative one in as you read the constraints. There's two variables for every one of these demands. So you got equals 200, equals 150, equals 350, equals 300. But notice here's x43 plus x38, I think that says, say, equals 300. You're just putting ones there. You're taking down the constraint. You look at the variables on the left, and you put in a 1 underneath the variable name on the left-hand side of this. This is all data entry to make it look like the constraint and the objective function that you're writing after you drew your network. You read the story, you draw the network, you write the constraints and the objective function, you set it up on Excel. Where do you think the optimal solution is going to be placed in this problem? Do you see a place for the optimal solution? Where? Give me a cell location or at least one. I hear D15, all D15. Here's where the optimal solution is going to be placed. So these are all just zeros right now. Nothing's there. Here's the first equation being written on this spreadsheet for the objective function. And it's going to take every one of these optimal solutions multiplied by the objective function cost per unit and add them all together. So this could be x15 times, t15 times d12 plus e15 times e12 or whatever letter I'm on, f15 times f12 plus, or it could be some product. You can use that as a replacement. What is it on this case? Yeah, I did the long way. D12 times D15 plus E12 times E15. You see the logic there, right here. And when we open up solver, the first question is set objective. There's the cell location. Now, this is the left-hand side. So let's talk about the first one. Less than equals 600. This is constraint 1. There's the 600. What do you think is here using cell locations? Look up there. And it happens to be, even though there's only ones in D4 and E4, it's a lot easier just to do the whole thing. The rest are just blanks, which are really like zeros. They won't have any effect at all. Copy, paste. You write them all in the first one, get it out of the way, copy, paste, save a ton of time. If you only had D4 times D15 plus E4 times E15, if that's all you need, then you'd have to go to this one and type it in. Then you go to the next one and type it in. But if you just do the whole thing in one thing, then you just copy paste. So if you notice, we got D4 times D15, E4, E15, F4, F15, all the way to O. And then if I go to look at dollar signs, are there any dollar signs up there? It means when you go to copy and paste, the dollar sign is telling Excel, don't change that number, don't change that letter. Always use that cell location, because every one of these are using the optimal solution mode. So that's where the dollar sign should be. When I copy and paste it down, what will that D4 at the start turn into? I copy and paste it here, the D4 is going to change because there's no dollar signs there. D5. D5. If I copy and paste down here, the D will turn into what? D6, and so will the other numbers. And so that's why you get all the work right here, include all the variables, copy, paste, it will automatically use the next row, the next row, the next row. But always multiplying times this, that's why you see the dollar signs at D15, E15, F15, they all should have dollar signs going across. So sure enough, D5 times blah, E5, F5, D6, FE6, F6. So it's not too hard to set these up. Here's your less than equal, here's your equal, here's all your equals also, right? So we have equal, equal, I can bunch these together, and then we have two less than. Here we go. Data, solver. We move this over. Set objective. If you right there, it should be cell E18. This is a minimization. We're going back here now. We want the optimal solution in D15 through O15. Sure enough, D15 through O15. The left-hand side. We're going, whoop, didn't mean to change that. What was it? Oh, I just added something to it. So what happened? Okay. Now I'm going right here for the constraints again. We went back over a little. I'm gonna delete that one. I'm gonna delete this one, just to show you how to enter them real quick. This is usually where people have problems with the constraints. So I'm gonna add, I'm bunching together the less than equal because they're right next to each other here. There's two of them, so the left-hand side for this first constraint would be these two cells. Then I make sure it's the less than equal. The right-hand side would be these two cells. So I just took the top two constraints and did them as one because they're both less than equal. I'm going to click Add because I want to do another one. And this one's going to be from constraint 3 here all the way down to constraint 8. So D23 through D28. This one has to be equal. And then the right side is the same, 23 through 28, but G. So there's 23 through 28, G23 through G28. So we did all of those constraints in one move instead of typing each one individually because they're all equal to. Just kind of saving time. So it looks like 2 constraints are there, but really there's 8 of them. These 6 are bunched together and those 2 are bunched together. You ready? Can we solve it? Is everything else okay on here? It's a simplex method, right? We're good? So this, now, when you look at blah, blah, blah. I'm not going to do it right now, but yes, the other reports. Hey, it always jumps. Is this it? No, that's not even it. This it? This is it. You ready? In this transshipment problem, how many is going to get to our distribution centers, the center node, coming from our first supply location? How many will get shipped? 600 will be coming out of our first supply place. Right here, constraint 1 is all about that first node, and there's 600. And are there any left over to ship somewhere else? No, all 600 are going to go out somewhere. Matter of fact, tell me where the 600 are going. Where are the 600 going? Name one place it's going. Name, not place, but number. You'll see, here's all the shipments. Some of them are coming from the first supply node, which is numbered 1. What's the first supply node always? 1. So you're looking for X1 something, wherever it's being shipped to. You see any of them? X13. 550 out of the 600 are being shipped to the center node number 3 distribution center. Another one. 14. There's 50 more being shipped from the first node to the other middle node distribution center. And look what they add up to, 600. It says 600 being shipped, so I don't even have to look. There's no way there could be another X1 anything with something being shipped. They already add up to 600. Let's go with constraint 5. Constraint 5 is that first demand node. So you'll see no X5 anything because it's a demand node. It's being shipped there. But where's it coming from? What's coming into 5? From where? Name an X something. X3 what? 5. X3 5 right there. There's 200 of it. And they can only get 200. So there shouldn't be any X something 5 left.
X4, 5 is
4, 5 is?
0.
It should be a 0. There we go. And if there was something else 5, it should also be a 0 because all 200, all 400, excuse me, I'm sorry, all 200 are coming right there. This is the kind of questions you suspect when you have an output, whether it's a software output or an Excel output. It may say, now we would have names up here, but let's say this is Detroit and that's Lexington. But you're going to look at this output. You got to look at the story. You got to say, okay, which constraint was Detroit? Which one's Lexington? Oh, that's X24. Then you come back here. You go. The question will say, how many is being shipped from Detroit to Lexington? You've got to find the optimal solution for X24. Once you figured out that I'm asking about X24, and you'll go right here. You say 100. Is that 100? Is that a 1? 4. That's a 4. 400 units. When you're up real close, it's like some of this disappearing. It almost look like different numbers. This is posted. Should be used as a reference when you're getting ready for the next quiz, because there's for sure a picture of an Excel spreadsheet on your next quiz. And you're going to be asked questions like this. The solver might be open, asking you what do you enter in. So you don't necessarily have to do Excel during the quiz, but you have to know how to read Excel during the quiz.
Do you know the function that makes all cells that are
formulas?
Yeah.
Yeah, I can't remember it. It's an easy one. What is it, guys? Isn't it D something or F something? Nobody knows? There's something you can do, now all the equations will all of a sudden come here.
Yeah.
You don't have to click on it, you just can see it. I can't remember what the function is.
Somewhere in the view tab, maybe?
Yeah, I can't remember. Somebody figured it out, send them my whole over.
It's the tilde.
Oh,
is it?
Now listen. Okay, here we go now. Oh, wait, is that an output? Yeah, right here. This is the same thing as the Excel output, but it's the software output for the same transshipment problem. And I'm going to say to you, well, I made up Detroit Lexington, and it was a 4-2, so I'll do Detroit Lexington again, and I'll say how many are being shipped from Detroit to go into Lexington. And you're going to say X42. Where is it? There you go. Wait, what was on the Excel? Another planet. Wasn't there an X24 right there?
4-2.
Oh, thank you. Let's go back to this one then. Whoop. Now, Detroit to Lexington, which is X4, 24, which is 400. Same exact answers, just being thrown at you a different way. Again, we didn't learn these, so don't worry about them. We won't be quizzed on them. All right. You know what? I want to show you a different one real quick, just to make sure we're all on the same page. Transshipment. That's not it. I don't have transshipment, so forget about it. No problem, right? Yeah, let's go back to this output. If we ship this recommendation, and we got all these shipments made, what's the amount it will cost us to make these shipments this way? Total. Anybody see it? I heard it. The objective function number at the top, that value, is the minimized cost. And even if we found a different way to ship these, no way we could get it lower than 5,200. And that's the ultimate goal, so let's just ship them. Why look for an alternative? Let's just ship them. That's as low as the cost we can get it, no matter how much more time we spend on this.
Do you have optimal values for like a transshipment problem?
There's
Not
not
optimal values, sorry, like
the rest of the output?
price, like
Dual price.
dual prices, yeah.
Yeah, I thought I did. I just opened it up and it wasn't there. All right, look at this one. Wait, you know what? I want to read this story real quick just to make sure you see this transshipment. I want you to visualize it, and then we'll go on to assignment. It says, we need a constraint for each, that's not the story. Is this the story? Here we go. Consider the transshipment problem faced by Ryan Electronics. Ryan is an electronics company that has a production facility in Denver and Atlanta. Components produced at either of these facilities may be shipped to either of the firm's regional warehouses. These are the words that are kind of coming at you saying transshipment, because it's going to continue on saying, and then from those warehouses they get shipped on to, that's where you go, oh, it's going from one place to another transshipment. That's the key to these, is recognizing which one. Once you know which one of these 4, or possibly 4, maybe 5, most likely 4, you jump to whatever triggers your mind to say the logic behind this. And they all have such similarities, the logic's the same for a lot of them. Every node is a constraint. Every arc is a variable. All the ones on the left are less than equal. All the ones on the right are equal constraints. So anyway, it will say, components produced at their facility may be shipped to either of the firm's regional warehouses, which are located in Kansas City and Louisville. And then from these warehouses, the firm then supplies retail outlets in Detroit, Miami, Dallas, and New Orleans. That part right there is what you have to recognize is being described to you as a transshipment. You have to be able to read this and say it's being shipped from somewhere to somewhere else. And that extra step is what makes it transshipment. The transportation problem used regional warehouses or used the word distribution centers. You cannot rely on the word distribution center. It means, oh, that's a transshipment. It's not the word as to what it's called, the note's called. Is something being shipped somewhere and then shipped again to somewhere else. That's what makes it a transshipment. That reminds me. Let's go to page 270. Right here. All right? Look, yeah, which one? Which one? 13. Verse 13. Starts at the bottom down here. That's right. Why is that so light? We gotta get the mood lighting again? Okay. says, what does it say? It says, sports? Sports of all sorts produce, distributes, and sell quality skateboards. Its supply chain consists of 3 facilities located in Detroit, Los Angeles, and Austin that produce skateboards. The Detroit, Los Angeles facility can produce 350 skateboards per week, but the Austin plant is larger and can produce 700 skateboards per week. Skateboards must be shipped from the factories to one of 4 distribution centers. Stop there, it's a transportation problem. That's it, but let's keep reading. Then it says, our distribution centers are located in Iowa. Can you see the top listing? Located in Iowa, Maryland, Idaho, and Arkansas. Each distribution center can process, repackage, mark for sale, and ship at most 500 skateboards per week. Skateboards are then shipped from the distribution centers to retailers.
Wait, isn't it transshipment?
It's transshipment. Right, that sentence I just read makes it transshipment because it was all about going from the factories to the distribution centers, and then that sentence said, and then it goes on from the distribution centers to these retail outlets. Now it's transshipment. And that's what you got to recognize. That's the hardest one for most students is this transportation or is this transshipment? And those are the words you want to recognize to be able to tell the difference. That's all I want to point out. All right, let's go back here. Assignment. Kind of gave you information about this story already. It says, let's consider the case of Fowler Marketing Research, which has received requests for marketing research studies for 3 new clients. The company faces the task of assigning project leaders to each of these clients. 3 individuals have no other commitments and they're available to be project leaders for these assignments. The time required to complete each study will depend on the experience and ability of the project leader assigned. The 3 projects have approximately the same priority. The management wants to assign project leaders, here's the key word, to minimize the total number of days required to complete all 3 projects. As that right there is saying, it said, hey, for every project leader, they've been able to estimate the amount of time it would take to complete a project depending on which project leader is doing the project. But then it says the goal is whatever these assignments are going to be, to have the number of days to finish all 3 projects to be as low as possible. So we look at this box. If we happen to assign Terry as the project leader to client number 2 for that project, we think it's going to take 15, is this days, right? 15 days, right? Days. But if we go ahead and assign Terry to this one, it'll only take 9. Well, your first thought is, hey, I'm going to assign Terry to this one, 9. But now Terry's not available for this, for this client's taken care of and Terry's out. So now all we can look at are right here, just these numbers. And if we're going to actually go with probably the 6 here, so now we have to figure out between what's left. 18 has to go here. And we would never want 18. And that's where you go trial and error. Okay, let's try then. We'll do 10 here then instead. And then you go like this.
The least amount.
What this is going to do, and don't get me wrong, in real life you have 20 project leaders, 30 clients, or whatever it may take. So you just can't sit there all day and do this. I mean, this is what it's called an assignment. What we read that made this assignment is the logic behind it didn't say we can supply 500 leaders if they come from, project leaders if they come from, Detroit. We could have 12 project leaders if they come from Chicago. Didn't say that. It just said we have 1 project leader available for each project. And each project client needs a project leader. 1. There's the 1-to-1 ratio, and that's what jumps out at you and say, oh, this is assignment. And with assignment, your nodes, and you may have to draw the network. And every time students are in a hurry doing assignment drawings, they always forget to put the 1s on the outside. I don't want you to forget that. That's assignment right there. And the 1s, what they do for you is they trigger, oh, I've got 3 constraints, all less than equal to 1. And then over here, I have 3 constraints, all equal to 1. You get each one. We drew it out and it looked like this. Here's your 1s. Here is the amount of days each project leader would take if they were assigned to that client project. All right. Let's write, first of all, how many variables will be the objective function? 9. There's 9 arcs there. The objective function, we factor them in. min. Let's get the first variable. Min, help me with the first variable, x what? 1, 1, what number's in front of it? 10, x, 1, 1, plus, let's do another one. 15, is that what that says? 15, x, 1, 2, plus. You just take each arc, and you write it in, where it's coming from, where it's going to, and that cost associated with it, it's right there on the arc. You drew the network. You then have all your constraints, when you get down here. Here are the 3 project leaders, less than 1, less than equal to 1, less than equal to 1. Here's the 3 clients, equal to 1, equal to 1, equal to 1. There's the 9 variables that exist, each one of them with the number of days it would take if that project leader were assigned to that project. I want to go back here and say one thing before you saw that, I forgot to say it. If we were doing the constraint for client number 2, how many variables should there be in that constraint? If just count the arcs touching that node. That's all. You know there's 3 variables. And you won't get these wrong. Oh, there's 3, because there's 3 arcs touching. That's all you need to remember. And you know you're going to be putting 3 variables down. And then you feel the pressure of time, and you start throwing in the 10 and the 15 and the 9, and you just took all your points back. Well, for me. So, now, you wrote this out, just like that. And now you're going to enter it into Excel. You see the table at all. First constraint, all 9 variables are across the top. We're going to see in a minute, but I want you to visualize them. All 9 variables. We would then go find x11, put a 100. Find x12, put a 100. Find x13, put a 100. Skip all the rest of the variables. Less than equal to 1. You don't even have to put less than equal to 1. You go to the next constraint. Find x121, put a 100, 100, 100. Less than equal to 1. That's exactly what Excel is going to look like. When you set this up, looks like this. There's all 9 variables. Here's our less than equal to 1, the top 3. Here's our equals to 1. And x11 plus x12 plus x13. There's nothing else there. Less than equal to 1. x21 plus x22 plus x23. Less than equal to 1. So everybody see the logic behind taking it from the story, drawing the network, writing the constraints and objective function, then being able to enter it into Excel and set up that table at the top. Does everybody see all this? Then the next step is, if this were on a quiz and I said, if I went to this cell right here, E18, what would I see? Using cell locations. And you'd say, help me out here, what would I see there? First it's a min, but it would say, what cell location first? What is it? D what? D11. D11 times, what other one? D15, that's right. Plus, what's next? E11 times E15.
Some product did.
Yeah, sorry, sometimes. So it's every one of these times the optimal solution. There. That's what's right there. Okay, think about this now. Jump into a random one on purpose. Think about what should be right there. There's I'm preparing you for the quiz. This is exactly the kind of question you're going to get. You got a picture of this, and I'm asking you what would be there. You got to know the logic behind what was entered for that one right there. Look,
Is it D7 times D?
let me see. I got to line it up here. That's constraint 3. Even though there's no numbers here, I would do it all the way across. D7 exactly times D15, E7 E15, F7 F15.
Plus is in between.
Plus is in between each one, that's right. Oh, I already clicked on it. It's right up there at the top. 7, 15, 7, 15, 7, 15, all the way across.
Can you not sum product the constraint or no? Like,
I mean, you sum product there either. Yeah, you can sum product that, absolutely. Sure.
I just wondered because you had the point on it.
Okay, before I open up Solver, all right, go ahead.
Can you do something with some product or just show us how to do it?
Me?
Yeah.
I hardly ever use it.
Can you do it though?
Oh, yeah, I can logically figure it out, because, let's see. We're going to take all the D through L11, this is the left side, times all the D15s through L15s. That logic sound correct? So I think it's going to go equals sum product, and sum product means multiply then add. Multiply then add.
You have a
Multiply.
bracket.
Huh? What that?
You have a bracket in
Hey,
between.
this is what we get for spontaneousness. Simple forget what product. Parentheses. So this side is asking for the array, which is going to be, which one is this right here? All of these times and added to, got to put a comma, all of these optimal solutions. That's it, right?
Yes.
Let me do my end parenthesis, right? Same answer, 0. We'll know if it works or
Therefore,
not.
it's right.
I'm going to solve it now. I'm going to see if both of these are right. But let me point out again, what I did is, I said all these D11s, so from here all the way here, need to be multiplied here all the way here and sum of the products of those. So those are the two arrays on the left and right. And if I did it right, we're going to get the same answer that when we solve it. Ready? Data. Solve it. Is the set objective right here in our sum product? Oh, we can't do them both at the same time. You can only do one or the other. Shoot. Let's do this one first. Is this a max or a min? Changing cells at what location are the optimal solution going to be placed? Give me one cell location. D15, thank you. I'm going to go ahead and hold the left click down and drag it all the way to L15. So from D15 to L15. Constraints, you ready? Add a constraint. These first three are all less than equal. I'm going to group them together. There they are, less than equal, right hand side. These first three right here. Then I'm going to add the left hand side for all of these equals right here. Change this to equal. And then the right hand side are these last three right here. Hit OK. There's all the less than equal, the top one. There's all the equals. Do I have to do anything else, DBC? That's right. It's just, look at it, always switch spreadsheets when I get there. So my question is, the second project leader, I think the name was like Carl or something. I can't remember. C-A-R-L-E or something like that, right? That was the second project leader. And I gotta go back to the story real quick here. Right here. Which project is project leader Carl? I don't know if that's Carl or not, but where is that project leader going to be assigned to? So let me get back to this output. You tell me, go to the output. Where is that project leader going to go? Client what?
2, 3.
Carl is lead project leader 2. So the first number, 222, there's only a 1 here, not 21, not 22. Project leader number 2 is going to client number 3 in that project. The first project leader is going to client number 2, and the last project leader is going to client number 1.
Why if they all start on the same day, does it take 26 days? Wouldn't it take under the max number of days that it takes?
This is billable days.
Oh,
We're trying to minimize billable days.
So it's total days.
We have to pay, yeah, we got to pay for 26 days. Usually in cases like this, though, you have a contract with the clients.
But do you
And the
understand
contract's in cement. You can only collect so much. So now your job is, how do I keep our expenses as low as possible to have that gap between what we're being paid and what it costs to have that profit for the company?
Right. But total they were like.
Yeah, they're working the
16
same
days.
day, possibly. That's
Okay.
true, but we're still paying for all 26 days.
Okay.
We got to pay them all. It's the least amount of days that we have to pay them to keep the cost as low as possible, to have that gap between revenue and our cost, gross profit, to cover all the other stuff, and have something left over for net profit. Here's where companies make mistakes. Part of that net profit should always be held on to for bad times in the future, called retained earnings. I know you guys had accounting. Retained earnings is the key for companies to make it through rough times. And too many companies don't plan for that, because when they have a bunch of shareholders who are saying, we want money, they do dividends. And it comes out of that net profit that could have went part into retained earnings for rough times. I want to tell you, a company that will always be here now is Apple. Apple realized for the first time when they almost got bankruptcy that they focused on, we need to have retained earnings to make it through hard times again. And they've been focused on that for so many years now that they have, like, I can't remember how many billion in cash in retained earnings. So this virus thing is gonna hurt their revenue. You know, plus they had to stop production, I think, over in China in a couple of plants. So there's gonna be a big deal. But they're gonna make it through. You can count on it. And when the market goes down like this, I've been buying these last 2 or 3 days. And not that people are gonna buy Apple stuff, so I didn't buy any Apple stock. But I know Apple will still be there if this gets bad and the market truly crashes, because panic sets in, Apple will come out of it and will still be there at the end. Because they have so much retained earnings, they were so smart about taking some of the profit and hanging on to it for bad days, that they can make it through any storm. They actually at one time had more cash than any other company in retained earnings, any company in our country or maybe the world. So that's how prepared they are for the possibility. Oops, we shouldn't have done that item that we thought was going to sell millions of. We made a mistake, but we can make it through it. Let's keep innovating until we find that iPhone again. Let's keep going. And that's how you do good business. A lot of companies aren't at that point where they realize that. So you're going to have, if this market starts going to a panic, there's going to be an incredible amount of company bankruptcies will follow because they were not prepared with enough retained earnings to get it through the hard times. That's the mistake many companies make. It's impossible for new companies because they're just too new to be able to have profit enough to put it into retained earnings to get through bad times. So a company starting right now, and if we end up having a panic and they were relying, their whole budget and forecast were based on a certain amount of revenue, this will put them out of business because they didn't get it. They didn't have enough time to get a retained earnings. They picked the worst time to start a new company, right before something's going on like this. This is happening every day. We hear tons of bankruptcy. I want to make sure I point out something to you. During the crash at the end of 2008, if you go back and look how unemployment first filings, that there's a statistic where people file for unemployment the first time, meaning they haven't been on unemployment. At the end of every month, there's a stat that comes out how many people apply for unemployment for their first time, they haven't been on it for the previous month. And in January 2009, all the way to like April or May, there was over 500,000 every month getting laid off. Every month, 500,000 people lost their job. And so it was exponentially compiling like that. And that's what could happen again if a panic sets in. If they start saying, this virus is now going from person to person in communities, no relation to somebody that came over from China and happened to have the interactions, or if somebody on that cruise ship now in America had interactions. They can't, the one case in San Francisco cannot be connected to anything. It's the first one called community association. And once that happens, this could turn into a panic as far as the market's concerned, which means companies are going to be going bankrupt, but not Apple. That's how smart companies are, finally, when they pile up money to make it through unexpected triggers like this. I call it the trigger. Because it's triggering, possibly right now, it's triggering fear. Right now it's just fear. But it could turn into panic.
So the panic is like panic selling, so the price crashes?
Yeah, well right now, the stock market is down about 11% for the week. That's fear. If it turns into panic, it will go from 11%, it may even go back up and then bam, like an elevator, in 30, 40, even 50% if a panic sets in. And so many people are complacent about their retirement plans. They've been at this company for 20 years. They've always relied on a financial advisor to just put it in whatever they think it should be put in. But when something like this is coming, you should have your password and username ready because you've been putting money in your retirement for the last 10 years. And you get on there and you start shifting the money from these mutual funds connected to the market to the safe fund called the money market fund. Every retirement program has to offer a money market fund. It's a safe haven, like a savings account. They're still making 1% if the whole market crashes, because it's like a savings account. I mean, it's the safe haven. But so many people are greedy and they want to put me in the risky one. I'm going to make some money. And they don't see this coming. I keep pointing at this because if I had Yahoo Finance up right now, you'd see another 3% today lost. So if someone, a friend who's been talking to me every day lately because he's in a panic, he's got 350,000 that he didn't move, even though I've sent him 3 emails in the last couple of months telling him to get at least half of that out of it. And so he's lost 11% now this week, That's gonna be almost $38,000 he lost this week by being complacent. Don't be that person. When you're young, you can take risks, and if this happens to you, you can make it back. But as you get older, you do not take this kind of risk all in the market. You only put maybe $175,000 when you're in your 30s and 40s, and the rest of it's safe certificate deposits or, treasury investments or something like that. And then as you get an old man like me, you don't even have this much in there, maybe only 50,000 connected to the market. The rest, your job as you get old, protect the nest egg. Don't lose it to the market because of something like this happening. Protect it. But, I've conditioned myself to where I can't help myself but look at the market 5 times a day ever since the late 80s when I started getting into investing. I have no choice. I have to look at the market 5 times a day, every day. But the market's open. So for me, I saw this coming. I mean, this news reports will already say this could be get out ahead. This could get out ahead. So I have almost zero in the market right now. So I'm still making money while everybody else is losing. That's what I was trying to convince people like this to at least get half out of there. He's almost as old as I am. He's got all of it connected to the market. Because that's been the craziest thing, and he just got laid off. So look at the combination of what's happening right here. Anyway, do you need to know all that?
It's useful.
You know what? Let's look at page 273. Sound like a river. Number 18. Let's go to number 18. 273. Is it up there? Kind of like. Okay, tell me what we're looking at here. This is a problem on your quiz. And it says, Cover Plus sells and installs. I gotta read it from over here. That's so light. Cover Plus sells and installs floor covering for commercial buildings. Brad Sweeney, a Cover Plus account executive, was just awarded a contract for 5 jobs. Brad must now assign a Cover Plus installer crew to each of the 5 jobs. Do I need to keep going? Trevor said it. Did you hear him? Anybody over here hear it? Do I over here take a guess? What do you say? Assignment. There has to be a carpet installer team, one of them, assigned to each, is it called a job? Each of the 5 jobs. It's going to be a 1-to-1 ratio. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sometimes it's not 5 to 5. We're not going to get into the dummy nodes when these are not the same, but just to let you know, if you were drawing this out, you would have ones on these 5 nodes, because they're going to only one of them get assigned to a job, and on these 5 nodes on the right are the jobs with ones on the outside. That's how you recognize this. When preparing for the next quiz, and you're saying, I'm going to study chapter 6, you need to study on taking a random problem and see if you can recognize which kind it is. That's how you prepare for this one. That's the key, is recognizing which one of these you're reading. So that's where the back of the book in this case will come in handy. All right. Where are we going? Blah, 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 blah. Let's look at this output. Yeah. What's the project leader's name again? Carl. Carl. Here we go. Look at this output. Where's Carl going according to this output?
2, 3.
You see it? Carl's number 2. So 2, 1, 2, 2, 2, 3. And the only one that has a 1 here is 2, 3. So Carl's going to the 3rd client, the 3rd job. There's only 3 jobs, so there should only be 3 ones here. 3 different project leaders. And that's how the output's read. And then you go down here. Terry's going to client 2, 15 days. Carl's going to client 3, 5 days. Make whatever, 6 days. Look at the objective function value. 26 days, just like we had on the Excel. We have to pay 26 days of these project leaders and their team. That's what we want to be as low as possible so we can get that gap and that profit. And you can see how it's added up. If we took the 15 plus the 5 plus the 6, that would be the 26. Now, here we go. Here we go. Right here. You read all this at home. I'm jumping to the good stuff. There. No. Better stuff. Right here. Hang on. Where is it? Oh. Darn. The only difference between what you're looking at here is is that if this were a quiz, you'd have numbers here. These would all be numbers. You ready? Remember the rule. Every node for all of these represents what in the equation? What kind? Constraint. Same thing. How many constraints are there?
6.
That's right. Every arc represents a variable. How many variables are there? Let me stare. Yeah. You think 12, right? Or 13? I don't know. But that's what you think, right? That's right. Matt said, but I haven't told you about the two-way streets on shortest route. Shortest route has two directions on any arc between two middle nodes. Now let me repeat that. Any arc going between two middle nodes, not the beginning node, not the end. The smallest number is always a 1. The largest number is the end. Could be a 7, could be 8, could be 9, 6 in this case. Any arcs touching 6 are one-way arcs. Any arcs touching 1 are one-way arcs. But any of the arcs between middle nodes could go either direction. This is the weird part. Because they can go either direction, they represent two variables with one arc. So we have a lot more than 8 or 9 variables. Let me show you. I'm just going to go with middle ones right now. This is between two middle nodes, so that's 2. That is x25, x52, 2 variables. This one's between two middle nodes, x35, x53, 2 variables. This is between two middle nodes, x34, x43. And if we were writing this in the objective function, we would use the numbers that are going to be on the arcs. So if this were the objective function, let's pretend that f is a 5. This would be 5 times x25 plus 5 times x52. Both variables with the one number on each of them have to be in your objective function because it's 2 variables.
Can you repeat that?
You ready? How about, right? Let's do this one now. This is between two center nodes, so it represents 2 variables, 2 arcs. Even though you only see one, it goes both ways when it's between middle nodes on shortest route. So this would be, I don't know what number to put here for h, but let's just use a 2. If this were in the objective function, it'd be 2 times x34 plus 2 times x43. Both of them would be in the objective function as 2 separate variables. So we have 2 here, 4, 6, 2, 4, 6. Here's 2 middle, 8, and that's it for middle, right? 2, 4, 6, 8. And then 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 variables. Now at this point in time, if I said, okay, let's take the quiz, somebody's not going to see all 18 variables. Or the most common mistake is they forget that this only goes one way. It cannot, you have no such thing as an x31. When it comes from the origin, the very first one, it leaves, but nothing comes back. So that's why there's only 1, 2, 3, 4, 5. This is x12, x15, x13, x16, x14. And that's it. There's no 4, 1, 6, 1, 3, 1. Once it's out of the origin, the beginning, it's one way.
Is there only one origin and one?
There's only one. There's always one is your origin, and whatever the largest number is, some of these go 7, 8, 9, 10. Whatever the largest number is, that's your ending. And once an arc goes to the end, that's it. It can't go leave. It can't come back out. It's at the end. So that's why all of these are one way. x56, x26, x36, x16, x46. But there's no such thing as 64, 61, 63, 62, or 65. They're one way at the end and at the beginning. But in the middle, you got a whole bunch of variables in it.
Do we have to hit every node in shortest route?
Do you have to do what with every node?
Do you have to go to every node?
No.
So like,
No.
can your optimal solution have like
That's
a
right.
zero
Your optimal
route?
solution will probably not include a couple of nodes, for sure.
Okay.
But it could look like this. 1 to 5, then 5 to 2, then 2 to 6.
But it could skip a node.
Oh yeah, absolutely.
Okay.
since it's called shortest route, what you're gonna have here are either amount of miles between two destinations or a cost associated with getting from one place to another. And in this story, the employee has to get to this conference. And we as a company have to pay her for all the travel time. I think it's like $15 an hour or something. We'll read the story in a second. Plus, we got to pay for every form of travel. So if this this one probably is a plane. I mean, look at it, going all the way here. But we have to pay for the plane ticket plus the hourly wage of the employee during the time of travel. This one here could be a train. We have to pay for the train expense plus the time at the hourly wage. So each one of these will turn into the cost in this story if we use that form of transportation. And I want you to realize something. Let's say 1 to 3 is a bus. There's the cost of the bus ticket plus the cost of the time for the employee times the wage. But then this employee's not done. Then they're going from here to here. Now this is a taxi. We got to pay for the taxi and the time. Then it goes from here to here. Okay, now it's a train. Wait, what was the first one? Was that train? No, the first one bus. Good. So now we have train here. Now the employee's on the train. We got to pay for the time on the train and the train expense, the ticket. And here, right here, this is horseback. Okay? Horseback. We got to pay for the horseback rental and the time it takes, whatever it may be. You see my point, though? And that's what you see right here. This is every form of transportation for each one of those routes. So if you see A, we'll go back to drawing, going from node 1 to node 2, which is X12, multiplied by the cost, the train, 4 hours time plus $20 ticket. What is she getting per hour? Let me go here. 4 hours time, so $15 an hour. So $60 to pay her plus the train ticket. That A will have an 80 there. If this is on a quiz, it will say $80. So if X12 is in the objective function, $80 is next to it.
But that's just to go to one.
Just to go from 1 to 2,
Yeah.
if that ends up being the optimal route. Whoops. Now, look at, you know what? I want to add something to the story. You remember transshipment, the middle nodes? They're always equal to what? The middle nodes. 0, because whatever goes in goes out. Shortest route, every middle node's equal to 0, because whatever goes in goes back out. It's heading to the end no matter what happens to these middle nodes. No one's stopping. They stop for a second, switch transportation, and continue on till the end, whatever the route may be. So every one of these constraints, 1, 2, 5, 3, and 4, the right-hand sides are equal 0. Going over here. All right? Equals 0. The left-hand side are the variables. Count the arcs touching the node. But don't forget, if an arc is touching the node and it happens to be a two-way, you need both of the variables in the left-hand side. I'm purposely picking a middle node, like let's do 5. Look at 5. How many arcs are touching 5 before we talk about two ways?
5.
Is there 5? Oh, there's 4. Oh, there is 5. 5 arcs. So we know there's 5 variables, but at this point, are any of these arcs coming from another middle node? And how many of them? 3. Well, this is not coming from the middle node because that's 1. This is going to the end, so that's not, but the other 3 are all touching other middle nodes. So you have 5 plus 1, 2, 3, that's 8 variables would be on the left-hand side of node 5. And it would go like this. I don't have enough room here, but you ready? I'm looking at every one of these arcs touching 5. X, 1, 5, plus, oh, I almost forgot. Any arcs going into the node is either plus or minus, but the ones leaving have to be the opposite. And once you do your first constraint, you decide what's positive, what's negative. You have to be consistent on every one of those, of what's coming in and going out. These two nodes, whole different rule. I'm just talking about these middle ones. What comes in goes back out, so you have positive, negative, or negative, positive, and you have to be consistent. Node 1, the variables are always positive. You don't have to worry about that because they're one way. Node 6, the variables are always positive because they're just one way. Even though they're going in and these are going out, they're positive because it's the beginning and end. But node, what node was this? 5? This is node 5. Okay, follow along here. I'm making the ones going in positive because I started already. x15 plus x25 plus x35 plus x45, is that right?
Yeah.
x45, and that's all it's going in. The 6 can't go back. So now, minus x52, minus x53, minus x54, minus x56. 8 variables, 4 are coming into 5. Did I make a mistake?
No, I just have a question. If you put,
Which is-
Yeah.
You just like go into the.
No. When we're writing this constraint, the variables are all, but we're not writing that constraint, we're doing this one. This constraint, the variables are all positive. You have to start there and go, oh, is it going in, is it going out? You're gonna have 1, 2, 5 variables. This, all right? I don't want to keep jumping between ending or beginning and middle. I want to stick with middle for a minute, because I'm gonna get to the end, because there's something special about that too. Hang on, what? Oh. Go, yeah. We have 5 minutes? 5 minutes to spring break? Do we have an in-class assignment? This can't be right.
oh boy.